Okay, sorry, I should have made some preparation here. So we are currently targeting to prepare the software release by end of this week with updated and modified G library. As discussed before, the object detection, as it was planned by us, it's not going to be integrated at this point, so you will receive only the APIs. Not sure, Ivan, if you would like to more comment on it, what's going to be the part of the release from the perspective of the specific digital ping behavior, or if just the APIs is good enough.
원래 21일까지 준다고 했잖아.
이번
주. 이번 주까지 있어. 오케이. 2번. 아, 2번. Sorry.
Yeah, Ivan, can you?
Yes, if I can briefly describe. Yeah, so basically this will be or will include the logic which we agreed on the last meeting. So there will be new state object scan executing, and part of this object scan is also Q factor. And in the end of the object scan, you can choose what coil will be enabled and what will be the coil order for the digital ping. So this should give you freedom for your implementation of the receiver detection logic. Yeah, and in the meantime, we are also working on NXP detection logic for the receivers, but this will not yet be provided in the release because we still need to tune it. We have the initial idea, we have the initial test results, which we can detect the phone. We are able to scan all coils within 100 milliseconds and decide where is the receiver, but we need to work on some robustness here. So yeah, maybe we can align next week or on the next meeting when you will have some results from the object scan, and we can decide on which method we can use for future. If you agree on such a process.
Okay, thank you, Ivan. It's really appreciated. Okay, any questions? Any comment?
The software release is planned by next week or?
No. By end of this week.
This week and next week, or?
No. There's gonna be one software release by end of this week.
Yes.
And so you will be able to integrate it, use your method that you are working on because of the new state that is going to be implemented. And in the meantime, we are also working, let's say, on other solution. And the schedule is not, let's say, rock solid at this point. We are still in the process of validation, and we would let you know next week when this could be done. And of course, if it's even necessary, let's say if you get the positive result from your own solution, you can use your own. But next week we will decide.
Okay.
Okay.
Cool. Okay.
Okay, sounds good. Okay, sorry. So I will move forward. The Q factor. There was the discussion. There is external. I believe it's OPAMP, right? Used, and so you will have to, based on my understanding from the discussion between Václav and your team, you will have to use it. You will have to comment it.
그냥 달아서 써야 됩니다.
Is it correct statement? and we can close it.
이게 임종태 말로는 DM2 사용.
Just 1 second.
Mm-hmm.
Ivan, we have some question.
Yes, go ahead.
We already know the DEM2 is reliability is lower than DEM0, right? Is it possible to implement the QF measure with DEM1 to DEM2?
Firstly, we need to align on a naming. What is the DM1 and DM2? Is it a hardware revision or?
DM2 out.
DM2 our pin. That's the pin name.
DM1
You mean the CPS output? Yeah, you mean a CPS output pin?
Was it? Yes, correct.
So your question is if we can switch from NXP Q factor to the CPS Q factor to omit op-amp. Is it correct?
Because our proposed sample is implemented with without the OP-amp, and the because of we can improve some QF measurement without OP-amp, then the question is we can improve the QF measure without OP-amp because of 20 samples are already delivered to the customer. That's why we request the QF measure with DEM2.
Yeah, for this one, maybe it would be best if the Václav, our hardware guy, could join, because I'm a little bit confused which op-amp are you referring to, if it is DIM2 op-amp or Sense Q op-amp, which is for the Q factor. So I'm not quite sure which one you mean right now. So Michael, do we have a Václav somewhere?
I'm trying to call him, but guys, I believe that this topic has been discussed really many times, and I believe also Václav mentioned it a couple of times, Ivan as well, that this op-amp is, let's say, improving the stability and everything, because we, from the beginning, were discussing that the CPS solution doesn't seem to be good enough, and if you need to use it, there would be on your shoulders to evaluate it and let's say integrate it on your own. So if you have some working solution, let's go for it. But our team already spent really a lot of time, a lot of effort on it, and we unfortunately never, let's say, reached positive results. That's why it was really, if you look into our notes here, sorry. we always highlighted and emphasized many times that this external op-amp is necessary.
So yes,
Or-
Michael, but there are two op-amps actually in a game right now.
Okay.
So one is for the NXP-Q factor, and the other one is for DEM2 CPS output. So I'm not quite sure which are we talking about right now. So if you can, maybe
Okay,
if you can open the schematic and show us exactly, it would be better to align.
오케이.
이거
이메일이 있어요.
이거 이메일로 준다. 해서 물어봐요. 그래서 뭐 준다고 하면 닫아볼게. 네?
Wait a moment, please.
Okay.
Okay, Ivan, this topic I will discuss our hardware engineer one more time. And if we have any other hello.
Okay, so Václav is here, HS. So if you can point us to what op-amp we are talking about, just to make sure that we are all aligned.
So
HS? Maybe I'm gonna share probably the schematic. Or do you
Or
need
maybe
somebody
the
else here?
mail. You can share also the mail.
Oh, okay. Okay, just give me a second. I'm sharing it. It's this one, right?
Right.
Can you zoom it a little bit, Michael?
Yep.
Okay, so what's the concern?
PHEVS would like to remove op-amp, but we are trying to figure out which one first and need your comment if that's possible or not. So HS or RAM, anybody from PHEVS, can you please comment on it? One more time.
좀 보내달라는 것 같은데.
뭐를?
아까 요청사항 뭐였어요?
Hello? Can you please
Yeah.
comment, RAM? Or
Sure.
anybody?
못 쓴다고 정말 못 쓸 값이라고 판단되면 우린 호피 부추하겠다고 할 수밖에 없지 않나. 그래서 호피 부추하겠다는 결론으로 가는 거죠. 이렇게 말하면. 이상이 뭐였어요? 인상은 호핀 없이 DM2 아웃 써서 Q 팩터를 매주할 수 있는지.
Okay, can you measure the Q factor without the DM2 out? It's our first question.
Okay, so you want to measure Q factor through DM2 out signal.
Yeah.
Okay, I believe that we are tried that, and the Q factor was not accurate enough.
Was fluctuating. It was fluctuating a lot. So we had a problem with the EPP Q factor results. False positives and false negatives occurred during our testing.
That was the reason why we pushing SenseQ circuit.
Yes.
그래서 얘네는 OPM 추가해야 된다는 입장인 거죠.
So, your opinion, we need to have an OP-amp, right?
For the Q factor, yes.
Okay.
그럼 뭐 OPM 시방해서 NB한테 다시 받아서 시방해서 다시 줘야 돼.
Okay. Yeah. All right. Understood the point. I think we need to discuss internally for the additional OP-amp.
혹시 DM2로 Q 검토를 했다고 하는데 그 안 된다고 하는 이유의 데이터.
Currently on the board, you can basically reconnect it and do your own testing. From our point, DM2 out is not sufficient enough, but you can do the test on your own and reconnect it through the 0 ohm resistors, connect it instead of a SenseQ, and it should work. Correct, Ivan?
Yes, by additional software changes, we need to increase the scale of the signal in a CPS, and some additional changes. Yeah, you can use it.
Yes, but from hardware point of view, it's available for you to test it without this circuit. But from our point of view, the DM2 out is not sufficient, and we strongly recommend the SenseQ circuit.
이 투하고 썼을 때 안 된다고 하는 데이터를.
Do you have any back data for if we using the DM2 out for the Q measure?
Yes, let me find it. We shared it in a few months ago. But let me find it again.
Okay.
Yeah, I have it here. Wait a second, I will share it.
이메일에다가 메일로 정말.
All right. Please send again via the email loop. I will check. Okay. Please send me again. Yeah.
Okay,
Thank you.
I will share it again.
Yeah. Thank you.
Okay, Michael, so back to you. Probably can move to the next topic.
Okay. Thank you, Václav, for joining. Thank you for the discussion, guys. So I'm going to share the open item list again. I put the comments here. Oh, I'm sorry. Okay, Q factor. So we just discussed EPP casing missing the rubber part. You've been able to ship it, or it's gonna be later?
It's
Soon.
already to your side. I think in few days you can get it.
Okay, sounds good. Can you share the tracking number once it's available?
I'll check in and share it.
Okay.
So I think rubber part of the already delivered. I'll check again and I'll let you know the ship number.
Okay, sounds good. Okay. I will skip this one for now. D17S, I will skip it as well. still waiting for the samples, radio frequency interference, avoidance. So this is gonna be part of upcoming release by end of this week. So it's pretty much the same what was last week. So just this one software targeted, and sorry, this week.
One comment
sure.
here, Michael.
Go ahead.
For this AM radio frequency movement. So you can also reuse this API for your MPP project. So because currently we have no plan for new MPP release. So this API can be used for both. I will include the code for the both in this EPP release.
이거 AM 프리퀀시 MPP에 포함시켜야 돼요.
어떤 거요?
AM 프리퀀시 시프트 하는 거.
네.
둘 다 포함. Both of the MPP and EPP software need to include that frequency, radio frequency movement.
Okay, but this week we are planning to release the EPP software. But what I'm saying is that actually the API from the EPP can be used also for MPP. So you don't need to wait for the MPP release. You can use it directly from this EPP.
Okay, I understood. Okay, MPP.
Okay.
Yeah.
Thank you. I'm gonna skip this one, and there are two new topics. So we received the requirement for the standby current, 100 milliamp. So based on our internal measurement and investigation done previously, what we found out is that, and also you measured the same, that with analog ping and Q factor, the average current is around 135 milliampere. Based on our internal testing, with disabled analog ping and Q factor, there is still more than 100 milliampere is currently being measured. So based on internal discussion, we are considering actually, and would like to discuss it with you, just to disable the DC-DC. I'm not sure if Ivan, if you would like to share the screen or the picture, or if I should do.
You can post it in a chat. That would be the easiest way.
Okay, good. Just give me a second.
So what we found out that when we disable the DC-DC, the power consumption drops the 50 milliamps, so to the 50% of the standby power. So the question maybe to you from BHGVS, if you have any experience or idea how we can fastly disable and enable DC-DC. If we have some previous experience from other projects, of course we can use the enable pin, but after this the ramp up and ramp down of the rail voltage is pretty slow. So if you know about some faster approach, yeah, it would be appreciated if you can share.
Okay, I will check it.
Okay, good. And maybe one question around for this use case for the measurement of the power consumption. So are we considering only the state when there is no object on the transmitter? Is it correct?
Yeah, without any objection.
Okay, so just the transmitter is sitting there without any FO, without any receiver, just powered up. Yeah. Okay. Okay, clear.
Okay, thank you. And the last comment or last point I've added to the open item list: external current sensing. Excuse me. So currently, we will have to validate it if it's possible for the EPP. And Ivan, correct me if I'm wrong, but for the 50-watt solution, as you know, we don't have any way how to validate it because we cannot flash the certificate. We don't have actually any phone with the Chinese proprietary protocols. So we will validate only EPP, but for the 50-watt, that would be job for you. Does it make sense?
Yeah. Okay, but it's just a pending for the MCU changes from the customer. It's a very big topic from the in the Mercedes side. So I think I will have to check some time to make it that topic. So okay, I just keep this topic.
Okay. Okay, so I skipped a couple of items at the beginning, but actually there is nothing here. There's no issue here. I will skip this one for now because we are focusing on the pacemaker case. And and this is actually the question I wanted to ask you. So I understand that you were able to successfully flash the Chinese proprietary protocol certificate. Have you been able to validate with real phones? Is the API and everything working properly? Have you been able to reach 50 watts?
됐어요, 저거? 좀 됐다고 했네, 지금. 50와트. 50와트. 플래시 됐다고 했네.
키 인젝션이요?
네.
안 됐어요.
그냥 계속 시도하는 중.
계속 하고 있는 중. 뭐 그래서 다음 주까지 해보기로 그때 회의에서
진호가
다른 분. 경환 씨.
CPP가 그 발리데이션 지금 sorry, social Korean.
CPP 플래시는 성공적으로 됐다고 했고 발리데이션은 폰에서 지금 하는 중이다. 이렇게 얘기했는데 잘못 얘기했나?
하위 키 인젝션이 안 돼서 뭐 아직 그 하위 폰을 올려도 프로토콜이 안 도는 상태.
플래시가 안 된 거죠?
플래시 안 된 거죠. 키 인젝션 안 된 거죠.
누가 인젝션 됐다고 했어?
말해요.
That point is any other feedback from our test engineer side. So we just waiting for some test result.
Okay, I understand.
Yeah.
All right, so is there any other topic you would like to discuss today?
I'm just wondering about the CB sample for the 117. I mean 17. So is there any update, exact schedule for the mass production of the 2D17? Is it still?
Jan,
it's still going by the plan which is mentioned in this part. So the production it's going and it's taken at 3 months. Currently we are working on the samples, 200 pieces, and currently I will need to check where is the location of this sample, but it should be on the way to the NXP.
Okay, and I have one more question about the sample of the MCU. Where is the MCU now? The 200 pieces?
currently it's in the NXP process before it will be shipped to you. When we'll be prepared and we will know the tracking number, we will let you know.
Okay, so you mean the sample will be leaved soon, right?
Yeah. Based on the schedule, it should to be during the May we should manufacture all of this sample process and provide it to the BHEVS address which was provided.
Okay, when is the exact date?
There is no exact date. It's in the process.
Okay. What is your expectation? Because we are waiting for the SMT for the new board.
I will need to check with the team. I'm not, let's say, part of this organization which have the sample on the charge. When I get more information, I will let you know.
Okay. Thank you.
Just for my better understanding, guys, what is the plan with all those 200 samples? What's gonna be the scope of the board? Let's say, will you also address the wireless charging, or you will mainly focus on non-wireless charging parts? What's the plan here?
From our side?
Mm-hmm.
Some samples are made for the internal testing, and we will also make for your side. So I think we don't have the exact schedule, but yeah. When we have the sample of the MCU, I will update the schedule.
Okay, understand. What I was pointing to is, let's say these are gonna be some kind of, and Jan, correct me if I'm wrong, some kind of pre-production samples before all the, let's say these guys that are gonna be in 3 months are gonna be the production samples, fully production. So if you plan, let's say, to ship also from this first batch of the samples to customer, or I don't know, just wanted to be clear that there's no quality issue, nothing like that, and the expectation is met. Just wanted to be sure that we are all aligned.
From the customers
Okay.
sample, not fixed. So yeah, now we are on discussing.
Okay. So from these 200 pieces, are gonna be any boards shipped to customer as well?
Schedule is not fixed. It's just
okay.
Yeah, just a plan.
Okay, depending on the situation. All right, I understand.
But from my opinion, so suddenly customer may change to MCU someday. So we have to prepare a lot of things.
Absolutely. As soon as we get the parts, we will also start with the porting to new chips. So just wanted to be sure that we are all aligned. Okay.
Yeah.
All right. Any other question or topic for today?
Just one topic for number 26, HSC and trust provisioning for Android CT 2D17. Is there any information for us?
Well, again, Jan or Ivan, correct me if I'm wrong, but the HSC and trust provisioning, of course, these are, let's say, available on our Flexera, but of course you will have to update trust provisioning program. There is actually a user guide part of it, and yes, if I'm not mistaken, you should be able to modify it based on the user guide. but or Jan, do you see it differently?
No, I think it's pretty clear. The S2TP software need to be ported to D17S with our source code. So currently, it was mentioned by Ivan there, and it's on the BHVS to modify that because we don't know what is your plan, how to want to use the production. This S2TP software which we have there is mainly used for example, and it's fully function. So if you plan to integrate it or let's say validate it on your side, which should be run on 2D17S, it will be up to you. Currently, I think we have 2016 and 2D16S chip supported by our software release, but the porting to 2D17S, it should be very easy because it's just a small modification in the linker file with that, but the address and the rest should remain the same.
Okay. We just edit the small modification into a linker file. Is all of that is all of the different things, right?
First of all, you need to find the proper HSE firmware and with the proper configuration, which should to be, let's say, proper install in that 2D17S. I think this is pretty clear. Like that proper version of HSE need to be identified, and on the top of that, you have the S2TP software, which currently it's configured for 2D17S MCU. Sorry, it's for the 2D16S MCU and need to be reconfigured in the S42 Design Studio for 2D17S. That's usually it's very, let's say, simple task, and currently we don't know what is your production plan of this software, if you plan to integrate it into one step together with HSE, or you want to have, let's say, separated. We didn't have this kind of discussion before. Maybe we can set some discussion. What is your plan with the production? But from the last information from discussion with your team, you want to make it in-house, and how it's integrated and modified, it will be up to BHEVS team.
Okay. If we have some question for this topic, and if there is some problem, we will ask your team.
Yeah, we can provide some, let's say, guidance there, or but I think it's pretty simple from your perspective.
Okay, I understood. Thank you.
Okay.
Right.
Yeah. Thank you. Anything else?
Thank you. Nothing.
Okay, sounds great. Thank you, Ram. Thank you, everybody. Enjoy the rest of the day. Bye, everyone.
Bye.